Hey guys, glad you're here. So we're talking about graphing linear functions. And there's two parts to this quiz. I'm not sure if we'll be able to get through both in this video or not. But to start off, when you graph a linear function, first thing I want you to realize is the word linear has the word line in it. A linear function forms a straight line. So it can be any kind of line. It can be going uphill, downhill, vertical, horizontal, any kind of line, but it has to be a straight line. We're not going to be graphing any of these crazy things yet. You'll see that more later on. But for right now, we're dealing with linear functions, which are straight lines. And this is the slope-intercept form of a linear function, where m is the slope and b is the y-intercept. So we're going to be looking at that in just a little bit. So to start off, we want to find the slope. Now we have to remember that slope, we can find it a couple different ways. The first way is rise over run. If you're looking at a graph, you can find slope using rise over run, which is really the change in y over the change in x. That's another way you can represent it. Or you could do y2 minus y1 over x2 minus x1. We have a lot of different ways to find slope. All of them work. I'm going to go ahead and pick up points that cross the grid. So I'm going to pick those 2 points. And I'm going to do rise over run. I like to start at my bottom point, and I always rise up first. Like I got to rise out of bed before I can run to the corner store. So I'm going to rise up 2 spaces. So my rise will be 2. And then I'm going to run backwards 1 space. Now, when you move to the left on the x-axis, notice how you're going towards negative numbers? So that's actually a -1. But if that confuses you, like putting a -1 on the bottom, you can just look at the graph first and say, okay, this is going downhill, so I know it has to be negative. And so if you reduce this, 2 over -1 is the same thing as -2. So the slope here is -2, or it could be written as -2 over 1. Or the negative could be in the front. I mean, there's lots of different ways you could write this. Okay, find the slope of the line and describe how one variable changes in relation to the other. So to start off with, for slope of the line, we're going to pick 2 points. I'm going to pick 0, 0, and then I'm going to pick 5, 10, and I'm going to do the rise over run. Now, when I rise up, my change in y, or my vertical change, is 10. It goes from 0 to 10. And then when I run over, it goes from 0 to 5. So my run, or my change in x, is 5. So my slope here, if I did rise over run, would equal 10 over 5, which if you reduce that, it's actually just 2 over 1 or 2. It could be written either way. And then we want to describe how one variable changes in relation to the other. So this is distance and time in seconds. So let's see what happens. As the time gets bigger, the distance traveled also gets bigger. Like if you go all the way out here to this last point, as your time increases, go over here, your distance is also increasing. Or you could say as your distance increases, your time increases. Find the slope of the line and describe how one variable changes in relation to the other. So here we have an ATV, and this is gallons of gas in the tank, and this is the miles traveled. So let's just go ahead. First, let's find slope, because it says to find the slope. So remember, slope is, since we have a graph, we're going to do rise over run. So I'm going to start at the bottom, and I'm going to count how many I rise up. You can look at it from here or from here. Notice the triangle is going to be the same no matter which way you draw it. So you rise up 2 spaces, and it's always good to check the axis and make sure that's how it's actually labeled. But it goes 1, 2. It goes from 2 to 4, so that's 2 spaces. So we rise 2, and then we're running backwards. Let's see, these 4 spaces, but it's not just 4, because if we look at our x-axis, it goes from 0 to 40. So we're running backward 40. And even before you do this problem, you could look at this graph and say, okay, this is going downhill. I know this is a negative slope, so I know my answer has to be negative. But let's go ahead and reduce that 2 over 40 becomes 1 over 20, and the whole thing is negative. It doesn't matter if you put the negative on top or bottom. Usually you'll just see it put in the middle though. So the slope here is negative 1/20th, and it says describe how one variable changes in relation to the other. So we start here with gas at 4, and as our miles get bigger, as we travel more miles, our gallons of gas go down, right? So we start with 4 gallons in the tank, and then it goes down to 2 gallons in the tank after we traveled 40 miles. So as you travel more miles, you have less and less gas in the tank. The data in the table are linear. I shouldn't say is linear, but whatever. Use the table to find the slope. Okay, so we know it's linear, so now we just want to find the slope. We said at the beginning there's a lot of different ways to find slope. On the graph, we've been doing rise over run. That way doesn't make as much sense from a t-table. The other way we said was that you could do the change in y over the change in x. And the other way we said was that you could do y2 minus y1 over x2 minus x1. So since we've done a bunch of rise over run with the graph, I'm not going to do that again, but I will show you these two methods. So if you're just going to find the change in y over the change in x, you need to see how is it changing. Think back to those arithmetic sequences where we try to figure out the common difference. So if we look at the common difference here, 30 minus 24 is 6. 24 minus 18 is 6. And so each time you are adding 6. So the change in y is a positive 6. And now let's look at the change in x. 8 minus 6 is 2, 6 minus 4 is 2, 2, and 2. So the change in y each time you're adding, the change in x each time you're adding 2. And then if you reduce 6 over 2, then you would get the slope equals 3. But you don't have to do it that way. Some of you guys didn't like looking at the sequences and finding the pattern and the common difference. You could also just pick any 2 points. It doesn't matter which 2 points. I'm going to pick these first 2 points. My first x value is going to be x1, and my second x value will be x2. Same thing down here. The first one will be y1 and y2. When I use this slope formula, it's really important to me that I go ahead and draw my fraction bar and my minus signs, and then I just plug in what I need. So y2 is 12, then I need y1, which is 6. On the bottom, I'm looking for x2, which is 2, and then x1, which is 0. 12 minus 6 is 6, 2 minus 0 is 2, and that reduces to 3. And no matter which 2 points you picked, you would get the same thing. So the slope here is 3. When you look at a table, you can either do the change in y over change in x, or you can do the slope formula, y2 minus y1 over x2 minus x1. Which of the following is the graph of the equation? Okay, so this is where we said we were going to talk about the slope-intercept form. If you have a number that follows this form, y equals mx plus b, m, or the number attached to x, the coefficient with x, is going to be the slope. And this is supposed to say b. I don't know why I put a 3. It's supposed to be y equals mx plus b. The b is always your y-intercept. And your y-intercept is just wherever the graph crosses the y-axis. So where it crosses y-axis. So if we look at this problem, our slope is a positive 3. Because it's positive, I know it has to be going uphill. And I also know, without even doing any math, that my y-intercept is 4, which means it has to cross the y-axis at 4. So if I look at each of these graphs, this one crosses at 4, this one crosses at 4, this one crosses at 4, and this one crosses at 4. So they all have a y-intercept of 4. That doesn't really help us. Now we need to look at the slope. So since the slope is positive 3, I know it's going uphill. It can't be this one because that's going downhill. And it can't be this one because it's going downhill. Now when we actually do slope, remember slope on a graph is rise over run, so I always like to make it a fraction. If it's not already a fraction, I put it over 1. So we're going to start at 4. We're going to rise up 3, 1, 2, 3, and over 1, and that should be my new point, which doesn't match that graph. But if we look down here, if we go up 3 and over 1, it does match this graph. And you can also go down 3 and backwards 1, but this is the correct graph for that one. All right, we're going to do it again. And again, just a reminder, when you have an equation in y equals mx plus b form, the coefficient with x is going to be the slope, and the b is going to be the y-intercept, where it crosses the y-axis. So let's go ahead and check out a couple things first. First of all, my slope is negative, so I know it's going downhill. This one goes downhill, this one goes uphill. That's a goner. This one goes uphill, that's a goner. And this one goes downhill. My y-intercept is 2. This crosses the y-axis at 2, and that crosses the y-axis at 2. So that didn't help us eliminate. And then the slope, it says we want to, it's negative, so we're going to go down 1 and then over 5. So we're going to go down 1 space, over 5. This would be the line, and that's not what it looks like there, so that's not it. And here we go down 1 and over 5. That one is correct, so this one is our answer. All right, which of the following table matches the graph? So if you're given a table, I like to just sketch my own points. So and I do this very quickly and very, like, not officially, but if I have 0, 3, I'm going to have a point there, and then -6, -3 is a point here, and I could sketch that graph, and I could see that that is not the same because I don't have a point over here at -6, -3. So it's not that one. So then I could come over here and I could just quickly sketch another one for this one. 0, 3 is right there. And then 1, 8 is way up here somewhere. I ran out of room. And then 6, 1. So this graph actually kind of looks like that, which is definitely not it. And then if we come down here, let me scroll down a little bit to get myself, oops, I don't want those, just kidding. So when I come down here and I try to sketch a graph, I have a point at 0, -1, and then 1, 5, and then 2, 3. Uh-oh, that looks weird. That's not my line. And then lastly, if I sketch this one, I'm going to do it over here because I'm out of room. I have a point at 0, 3, 1, 6, and then -3, -6. And this line actually does match up with this one. So this is the correct t-table. An amusement park charges an entrance fee of $20 and the rides cost $4 each. Suppose you write a function for the total cost of entering the park and riding any number of rides. What is the domain of the function based on the given context? Okay, so first let's write our function. It's $20 plus $4 per ride. I'm going to let this be a letter X. Even though it's ride, I'm not going to let it be the letter R because that kind of just bothers me. So $4 per ride plus $20 to enter. This is going to be the function. And we want to know the domain. The domain is all the possible X values. Let me pause this so I can write. So your domain is all the possible X values. Or if you think about a function, you input a number and then whatever it spits out is kind of what we're looking at here. So we're looking at what value you could plug in for X. And if you think about X representing the number of rides, you can't ride negative rides. So it wouldn't make sense to like plug in a -2 for X because you can't ride -2. You could ride 0 rides. So 0 does make sense. You would ride 0 rides. The total cost would just be $20. Or you could ride 1 ride or 2 rides or 3 rides. You could ride 100 rides if you wanted to. It doesn't make sense to say that you could ride 1.5 rides. You can't ride a half of a ride. So here, our domain are all the possible things we could plug in for X. Since X represents ride, it would be 0 and all the positive integers. So let's see. Well, not that and not that, because we don't want just real numbers. We don't want decimals and stuff. Set of positive integers or the set of whole numbers. I'm actually confused on this one because whole numbers are like 0, 1, 2, 3, 4, 5, and then positive integers would just be the positive. I guess I guess this one, because we